One of the best books to crack coding interviews is Cracking Coding Interview. Okay, you can see that book image coming up on the screen. So in that book also the author talks about data structures, and she starts with arrays. So arrays plays a major important role when it comes to data structures. So spend some time on this video and learn how the data is stored and accessed using arrays. Hello all. In this video, we are going to learn about what are arrays. We're going to look at 1D and 2-dimensional arrays. And also we're going to solve a couple of C programs to understand 1D and 2D arrays better. And our focus would be mainly on how to store and retrieve the data using arrays. If you look at the definition of arrays, the definition is like it's collection of similar data types. Here in this example also you can see we collected all integer data types together and we call it as integer array. Similarly, if I wanted, or if I collected all characters, okay, into an array, then it is called as a character array. In that case, we are actually grouping similar data types like characters together. Also, you can have objects, array of objects, particularly in JavaScript. If you see, you will be dealing with objects oftentimes, okay, in that you'll group all those objects in array of objects. But coming here, we'll be looking at one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays, and multi-dimensional arrays as well. But in this video, we are going to look at one-dimensional and two-dimensional arrays. So here we can see the declaration part. This is how we actually declare an array. This is the data type followed by the name of the array, and the size of the array is kept in square brackets, okay. And if we wanted to initialize the array, okay, with 10 integer types, okay, this is an integer array of size 10, and here you can see the 10 values that I've actually given. This is one-dimensional array, and if you look at the two-dimensional array, the declaration goes like this: a of 2 comma 2, because this is two-dimensional array. By looking at this, you can clearly understand how a three-dimensional array would look like, right? So the initialization, if we wanted to fill this array with elements, we'll initialize like this: 1 comma 2 and 3 comma 4. So it is 0 0 0 1 1 0 1 1. Okay, we are going to look at it, how exactly it is stored, in the next slide. The two most important things when it comes to array is that we need to learn that how the data is stored in the array and how we can actually access the data. This is how a one-dimensional array looks like in the memory. Basically, this is an integer array A of size 10, and these are the values that I have given or assigned or stored these values inside the array A, okay. In array A, this is like you can call them as the blocks of memory, and here you can see the index. Always many developers or the beginners make this mistake that index, remember, index will always, array index will always starts from 0, okay. So if you have array of size 10, the last index would be 9. So it's like if you have an array of size n, the last index would be n minus 1. And also this is how we store the data in the main memory, or the data will be stored whenever you actually initialize a array like this, one-dimensional array. And this is how we access the data. If I wanted to access the third element, what I'm going to do is array name followed by that index. If I wanted to get 7, I'll give a of 7. If I wanted to get the value that is stored at 0th index, I'll give a of 0. And these memory blocks are contiguous, means they'll be adjacent to each other. And now we look at 2D array. This is an integer, two-dimensional integer array, and which is assigned values with these 11,2 and 7,84. And if you carefully understand, this is how the data will be stored in the memory. And in order to access this element, I have to give 0 and 0, 0 comma 0. Basically there is no comma, but that is how we actually use the jargon, okay. 0 comma 0, 0 comma 1. So if I wanted to get the element that is stored here, I'll give 0 comma 1. That is why a 0 comma 1 would give you or fetch you 2. And also similarly, if I wanted to get the value that is stored here, I am going to give 1 comma 0, that is 7 will be accessed when I give like this. We'll try to understand more this by doing hands-on C program. I opened my VS Code and created two .c files, learning 1D arrays and learning 2D arrays. So in this learning 1D arrays, what we're going to do is we're going to read and write data from and into 1D array. And also then we'll try to solve a program to find the minimum, max and average of numbers given in 1D array. So before starting writing this program, if you're new to the C language and the importance of main function and the printf and scanf functions, I made a separate video. I'm going to leave that video link in the description so you can go start watching that video and learn before you actually start diving into learning arrays. So directly I'm going to go start writing the code. So we already looked at the slides. This is how we declare an array. I'll give an array of 10. Okay, this is an array we just declared, not initialized. Okay, if I actually initialize the values like this, give equal to and start giving like 1 comma 2 comma 3 comma 4 comma 5, then I actually initialize. So what I can do is I'll give array of 5 and 1 2 3 4 5 I've given, and simply I'm gonna print the same. So we already understood, in order to get the element at first access is index starts from 0. So a of 0 would give my first number, and a of 1 2 3 4 5. So a of 1 would give 2 3 4. That's it. So a of 4 will have 5. Okay, so directly what I'm going to do is I'm going to compile my program, gcc learning, okay, 1D array. Okay, every time I do this mistake, I always forget how to forget including std header file, forget including the header file. Okay, what I'm going to do is again compile it, perfecto, and a dot out. Yes, 1 2 3 4 5, I've got it. You can see here the numbers that I've stored. In order to understand, I can give 10 20 30 40 and 5 just to understand whether the output is coming correctly or not. Yes, okay, the output has come 10 20, it's gone. Okay, so 10 20 30 40 and 5 has come, but the output is not clean because we did not put any spaces or new lines. What I'm going to do now is you can see that instead of writing these many printf statements, for suppose if my array is of size 100, okay, I can't put 100 printf statements. For that I can have an integer, I can have a loop. Okay, what we're going to do is we'll remove this. I'll put int I and I equal to 0, I less than, here it is 5 because size I already know, right, till 0 to 4 it has to go. So I'll put like this and directly I'll give a of I. That's it. So my starts from 0 and goes till 4. When it becomes 5, it comes out of the loop. And again, I made a separate video on loops. You can check it out before actually start writing this program. So printf new line so that the output would look neat. Now here I'll give space so that it would look neat. So I'm going to open the terminal. I'll push it to right. I'll close this and then CCC, perfect, no errors. 10 20 30 45, perfect. Now the output is looking perfectly fine. So now here, if I wanted to change my array, again what I have to do is again I have to change the initialization. I have to give 50 here. So instead of initializing, we'll ask the user to enter the size of the array and enter the elements into the array. Enter the size of the array. Let's set this. Enter the size of the array. And I'm gonna store the same in array. Okay, size, right? So I'm gonna put a size, and again now printf enter elements into the array. Enter values or elements, you can call anything, into the array. You can ask the user, but now when you read, right, you don't know the size of the array. So what I'm going to do is I'm going to give like this, and I'm going to take a variable I is equal to 0, I less than size many times. Okay, I'm gonna read scanf %d ampersand a of I. Okay, basically here we can't actually give a of 5 because the size is dynamic. User might give 5 or 3 or 7 or 10 or 100, we don't know, so we can't declare like this. So what we can do is, once the user enters the size of his array, here I can actually give int a of size. So whenever this program is run, it will become a process in the operating system kernel. It will actually run this process, and that process will start creating the memory in the main memory, and it will create a size integer array A with the size that user has actually given. And here we are actually reading the data into this array, and here we are actually printing the same, but here not 5 because it is size of the array that user actually have given. Okay, now we'll try to compile and execute the same. Okay, no errors, nothing. A dot out, enter the size of the array. I give 7, 1 2 3 4 5 6 and 7. Perfect. So the size of the array is 7, and I printed the same elements from the array. And we can play around with the output. I can give array size is 3, I can give only 10, 20, 1, 20, 30, and the output you can see 1, 20, 30. I can give like 100 also, okay, but it's going to be huge to enter and type. 6, so 6, 7, 8, how many values? 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So see, 10 values, the size of the array is 10, and 10 values are stored in the array, and 10 values are displayed from the array. And now we are done with the first part, that is reading and writing data from and into one-dimensional array is done. So now we are going to find the min, max and average numbers in the one-dimensional array. So for that, what I'm going to do is, again I have to iterate through the array in order to get the min, max, and here I'll iterate the same. Okay, this is what I'm going to do, and open, and well, I'm going to take variables like int min and int max and int average, or I don't even take average because I want to use an intermediate variable. So int min, what I'm going to do is I am going to give some big value, 99,999, and max value I'm going to give 0. Okay, and then what I'm going to do is, whenever I'm iterating through this array, whenever I find if a of I is greater than, okay, max, then I'm going to simply put max is equal to a of I. What happens is, I did the reverse thing. I actually gave max as 0. So obviously whenever it encounters an element which is greater than 0 or whatever the element, then obviously the max would be that. And else if, or what I can do is, again I'm going to put if my a of I is less than min, then my min is a of I, and I can simply print the average as, all I have to do is sum is equal to sum plus, I can give a of I, I'll get the total basically here. Instead of that, what I can do, I can use shorthand directly. I can use like this. It doesn't know what is sum, so I'm going to give int sum is equal to 0, or I can give int total equal to 0. And I'm going to give total here. So by the time I finish, the addition or the total of all the elements will be there in the total variable. So that's it. My program looks good. So I'm gonna write minimum is equal to %d, and it will be stored in min variable. I'm gonna give new line here so that it look nice. Min, and then max would be in max, maximum value would be in max, and then average average would be total. Okay, what's my total divided by my size. Okay, size of the array. That's it. It looks good. We are gonna compile and run it and check. Okay, let's go. Open the terminal and the GCC learning perfect. Out perfect. Size of the array I give 5, 10, 20, 30, 40, 50. Okay, my minimum is 10, perfect. Maximum is 50, perfect. Average is I have to actually do 90, 120, 140, 150. 150 by 5, 5, 3 is 15. Yes, perfect. It's working fine. But somehow here again the output and min max is not good. I mean, it's not looking good. So what I can do is I can put another printf statement here so that if anybody comes and execute our program also, the output will be clean and he or she can understand what our program is actually doing. Okay, this time I would like to just give 3. I'll give 1, 2, 3. Yes, min is 1, max is 3, average is 2, 3, 2, 6, 7. Okay, 7 by 3, 3, 2, 6, 2 point something would be coming, but integer type, it won't store the dot decimals, so obviously 2 is the answer. So now you can play around with this one-dimensional arrays and you can solve more number of problems on this, and this is what you need to understand, how we can actually read the data into the array and read the data into the array and also print the data from the array. These two things are the most important things, storing and accessing the data. Now we are gonna look at two-dimensional array. Okay, two-dimensional reading and writing data from and into two-dimensional array. And for two-dimensional array, what we're going to do is addition and subtraction. Okay, as homework problem we can actually do the subtraction of two matrices. What I'm going to addition of two matrices program, we are going to solve it to understand 2D arrays better. So quickly I'm going to start writing the program. So first we'll take an array of size 2, 2. Okay, that is 2 by 2. And I'm gonna initialize and give 1, 2 and 3, 4. Okay, these are the values. So let's try and print using the normal thing. How we are gonna, and integer type is a. Again, normally I'll forget this, include stdio.h a of 0, 0, and then 0, 1, 1, 0, 1, 1. Okay, it's comma is not there technically, but that's the jargon that we normally use. Don't get confused when I say comma and actually won't put comma there. Let's execute and check it. Here, what I'm going to do is gcc learning 2d arrays.c, no errors, nothing, a dot out 1, 2, 3, 4. Okay, technically it's printed correctly only 0, 0 is 1, 0, 1 is 1, 2, 3, 4. It's printing perfectly fine. Okay, but how can we actually print using this for loops? For that we need to use for within for. Okay, for I equal to 0, I less than 2, I plus plus, and again I'm gonna use j equal to 0, or in order to make it more sense I can actually go row is equal to 0, rows less than 2, rows plus plus, and I'll give it as columns. I'll call it as columns and calls plus plus. It doesn't know what is, so int rows, int calls. Okay, what I'm gonna do is I'm gonna remove this so that it will be clean. And inside this I'm going to use a printf statement. All I'll do is rows and then I give columns. That's it. So probably if you have had already solved the problems on patterns, okay, pattern printing, you might be knowing how actually this outer for loop and inner for loop will actually work. Okay, or we're going to debug it and then understand how this outer and inner for loop also works quickly. Okay, first what we're going to do is quickly compile and run it and check it. The output technically would be same. There shouldn't be any difference. Okay, so for us to make it more this thing, what I can do is here I can put printf percentile new line, here percentile tab. It will print like a tabular form. Okay, it's telling, hey man, I don't know what is this semicolon you missed. That's what it is telling. No errors, nothing. See, now it's coming like as if it's a matrix, right? 1 2 3 4 0 0 0 1 1 0 1 1. Okay, for those who are not familiar with this outer for loop and inner for loop, because I know that some of the developers or freshers, they still struggle, or experienced people or developers too struggle with this for within for. Okay, we'll try to understand. It's all about take a piece of paper and pen and start doing it. So initially my rows would be 0. Okay, and 0 less than 2. Yes, that's correct. So obviously I'll get into this loop. I mean, I'll come into this line number 14, and again there what's happening is my columns is equal to 0 and my columns is less than 2, and that is 0 less than 2. Yes, that's true. So obviously I'll come to line number 15, and here I'm printing a of rows and columns. So here if you see, a of rows is a of my rows is 0. Technically here I have 0, and now my column is also 0. So a of 0 0 will be printed, and again it will go into this for loop because this for loop is not exited yet. So now my column value would be 1 because I have given column plus plus, right? My column value would be 1, and 1 less than 2, it is true. It will come to line number 15. So here in line number 15, what happens? I'll have 0 comma 1, and again I'll go here, and the column value would be 2, and 2 less than 2 false, right? As it is false, and also we have tabular form, so a of 0 0 a of 1 will be printed 0 0 of 1, that is 1 2 will be printed neatly, and then it comes out of that inner loop and a new line will be printed, and then again goes here because we did not exit yet from the outer loop. Okay, now my rows would become how much? My rows would become 1. Now 1 is less than 2, that's true. Again it comes inside and it repeats itself, but we need to understand carefully here. The difference would be, now my row value would be 1 in all these cases. Okay, and again column 2 less than 2, so it will come out of the inner loop and again comes to the outer loop and goes to the outer loop, and outer loop equal to 2, so 2 less than 2, that's false. The 2 less than 2 is false, so it will exit the loop, and finally a printf or a new line will be printed. So initially if you are a beginner or starting to learn coding, so it's better you take piece of paper, always better to debug yourself line by line to understand it better. So okay, now we are done reading and writing data from and into 2D array. Now we'll do this C program for addition of 2 matrices. So for addition of 2 matrices, obviously I'll have 2 matrices, right? A of A and B, and I'm going to give same 1 1 2 3 4. So here instead of printing, or I'll simply give this, and here I'll do that logic. So the result I'll be storing in array of int C of 2 comma 2. Okay, it will be obviously in C 2 comma 2. So here simply all I have to do is A rows plus column plus B rows plus column. That's it. It will the output will be printed, but let's check it out what the output would be. Okay, what I'm gonna do is I'm gonna simply remove this. It's not needed for this. Okay, I'm gonna simply directly go compile it and run it. Yes, 2468, correct. Addition of 2 matrices worked perfectly fine. So I don't even need C matrix, okay, or otherwise I can actually store in C matrix like C of rows columns is equal to this thing, and instead of printing I'll simply leave it, and finally what I'm going to do is I'm going to print the C array, or mean C 2-dimensional array. Okay, I'm gonna remove this so that it would look nice. Finally, after this is done, my result will be in C. So printf percentile D and C of rows, commas, column. That's it. Now we'll compile it and compile it. Perfect. And run it. 2468. Perfect. But the output is not that clean, right? What I can do is I can give space here. Instead of space, I can give tab so that it would look nice. Okay. Perfect. 2468. It's working fantastically fine. Thank you all for watching the video. If you like the video, please go ahead and hit the thumbs up button and do like and share and subscribe to this channel, and also mention what are the new topics that you'd like to know in tech industry that is happening in the comments, so that I can go ahead and do videos on that as well.